Hey guys, it's Chris Fayte with Cheat the Game coming back at you. Today we're going to be taking a look at a different way that we can possibly compare out different values. This comes in handy for health, things of that nature. I ran into this problem when I was playing Dragon Age Inquisition. I was trying to find the player base address. It was easy enough to separate out versus enemies, but where I was having trouble was separating out versus my allies, because just about every single value I came across, they were in exact sync with each other. I looked in dissect data, I looked in the registries, I looked at the stack, the ESP and the EVP pointers, and they were just staying synchronized on the values that were staying the same. I could not find anything to compare them out with. Now I know I could probably go in there and backtrace a little bit and maybe find another location and try to look up comparisons that way, but I got to looking at something else, and I want to point to this at the Cheat Engine forum, and this guy here, Zanser, answered a great question in regards to how to compare a multi-level pointer. And I just wanted to give it a try just to see, and to my astonishment it worked. Now I can't sit here and honestly tell you why it works, but it does. But I'm going to show you how to do that. I'm also going to put the link up here in the description, so when if you go over here and read this, same individual is having similar trouble and did find a multi-level pointer that they could possibly compare out, and here was the answer right here. So I'm going to go ahead and get everything ready to go. I'll be right back with you, and what we're going to do is we're going back to good old step number 9 in Cheat Engine, because it keeps things a little simple, and this can get a little bit messy. So also I want to remind everybody this is more of an intermediate level thing, so if you are unfamiliar with step number 9 or how to compare out your enemies versus your heroes in health with allies and everything, you really need to go back and watch previous videos. Also go to Stephen Chapman's channel and really get the basics down, because we're taking a step up from basics now. We are in intermediate, and this is another way we can get a compare for our heroes versus our enemies, and I'll be right back with you. Okay, so we're going to be doing step number 9. However, we're doing the Cheat Engine tutorial 64-bit version. Okay, so this is what we're going to do, and we're just going to make it real simplistic here. So I'm going to go ahead and get started like we normally do by finding the addresses of Dave and Eric, Hal and Kit, and we're just going to kind of quickly do this. So I'm not going to, hopefully everybody at this level should know what I'm doing by now, so I hope I ain't got to explain all this. We're just going to find what writes to the address of Dave, and we get to our opticode instruction, and this is where we start. We've already looked in dissect data once, twice, maybe 3 times to see values changing. We checked the registries. We've also went to more information. We've looked on the stack, and Stephen Chapman gives a great lesson on how to do that as well. I'm going to put that link in the description also. Also, you can find it on his channel under the title How to Hack Game Maker Games. And we've checked through all these. We just couldn't find anything. Let's just say we couldn't find anything. So what other options do we have? Well, let's go back to dissect data for a second. And the way I like to do it is like this, because it automatically puts it at their base addresses. And this is all their addresses right here. That's Dave, Eric, Hal, Kit. We right click on them and open dissect data structures. Alright, now what we want to do is separate them into groups like we normally do, and we take a look around and see what's going on with it. And as you can see, we don't really have anything. Now I know we can go back and change this to 14, and that would be our compare offset, but let's just say we didn't know that, we didn't do that, and we looked all through dissect data, and as you see, there are nothing that we can even possibly use. as a compare. So what other options do we have? Well, we've already learned how we can separate them out via their names using string values, things of that nature. But let's say you have no other alternatives, we didn't know these were there, or they're not there, or they keep changing. Okay, so what we got next is multi-level pointers. Now sometimes Cheat Engine misinterprets these, so it's best to bring up dissect data on a fresh game at least 2 or 3 times to make sure these pointers are staying there, just in case. But for the sake of argument, we come to this pointer here. How do we check what these are pointing to? These are the base addresses of RBX. You can see here in the code, RBX plus 08 is our health values, which is right here. RBX plus 58 is pointing to this address, and this address is pointing to another address, and there's a value at that address. So how do we check that? Well, right here you see these little arrows. Let me bring this up just a little bit. You see these little arrows beside the pointer values. We can expand those out like so, and we get to look, and we get to look, and now just for the sake of time I'm going to go ahead and put that. And I know, yes, we can see it's the same structure as this right here, but we're going to pretend they're not the same, okay? Because we're going to learn how we can use a multi-level pointer compare, okay? And let's say we get to looking, and boom, yeah, we found one. We check it, make sure 4 bytes stays the same value. It does. So it is an integer at this offset, at this address, pointed by these pointers. Okay, sorry about that. Let's say we want to check that just to make sure. So what we can do is we go over here to Cheat Engine, add address manually, and this is what we're going to use right here. And this address, RBX pointing to 58, which is this address, 31995E8. Okay, so 31995E8. And as you see, it's pointing to this value, or this address here, and this is pointing to 14. So this address here is pointing to 14, which is the value we want, and that's for Eric. And if we put in their addresses, let's try Hal or Kit. Let's try Kit. Let's put in her address at the 58 offset. Let's see, 45284E8, and you can see at that offset is 2. So we found a group difference that is using a multi-level pointer. So how do we script that out? Well, here's where it gets a little bit tricky. Now, I'm going to leave that website link in the description. You can go read it. They explain it there just really well. I don't know if I could explain it as good as they did there, so I suggest you just go read it. But we're just going to go ahead and start scripting this out, and I'll show you. We're going to need to borrow 2 different registries to do this. So what I want to do is I want to use an AOB injection, and I'm just going to call it multi-test, if I can spell. Okay, so let's go back to our registry information. Now we can borrow any registries we really want, but it doesn't really matter because we're giving it right back anyway. I like to borrow registries that are not being currently used in that particular section of a function. So let's just say, for the sake of argument, we know that RBX is our base address, so we can't really, I'm not going to really use that one, so I'm going to use RAX and RCX, and we'll hand it right back to the computer directly after. So we want to go ahead and separate our enemies from us so that their health is continued to subtract, and we're just going to freeze our health at 100. Okay, so the first thing we need to do is we're going to push those 2 registries to save the values that they're currently holding. Now we can use them for whatever purpose we want. We keep our dissect data information up right here, and what I want to do is we're going to move RBX plus 58 into one of our registries, and we need to carry it to another place in memory that we can store that. So to do that, we need to allocate a new place, and I'm just going to say store pointer. I'm just going to call it that. We are dealing with a 64-bit, so we're going to be dealing with 64-bit addresses later on. I'm just going to save it as an 8-byte. And remember, anytime we allocate memory, unless you're using global allocate, we want to deallocate it. You do not deallocate global, but regular allocation, you want to deallocate it. And we also need to register it as a symbol. And make sure we unregister it also. There we go. Now these type methods here is just when nothing else seems to be working, and this is like a last resort type thing to compare out. It does work, but you may have to mess with it for a little while and make sure they're not changing also. You know how unstable multi-level pointers can be, so keep that in mind when you're doing this. But here we go. You found one, it stays the same, nothing's wrong with it. So here's what we're going to do. We're going to go ahead and move into RBX plus 58. And we got that information from our dissect data. We know that our code is RBX plus 08, that's our health. This is all the offsets RBX is pointing to at the moment and the values that they're holding. So we want it to go to 48, which is pointing to another pointer. Okay. So we're moving the value of RBX into RAX. Okay. So what I want to do now, now we're going to be in this structure. So that'll give us the value we want, pointing to this pointer right here, 45100DO. So now we have this value that we're working with. Now we need this to point to this. So what we're going to do, since RAX is now currently holding that value, we're going to move that into RCX. So RAX plus 14. So now that pointer is being moved into RCX. And now finally, also let's make sure that we make a stop for that just in case here. That's outside of, that's our new allocated memory, so we just want to make sure we put that up there. Okay, so now we want to move that RCX registry into our store pointer location. Now the reason we can't just do, the reason we can't just do it like this, let's say RAX plus 14, you cannot move a value into a value. That's why we're having to take this route. You can only move registry addresses into that location. So we're going to use RCX that's currently holding this value. So we're moving the value into RCX. RCX is going to move that value into our store pointer location. Now we can use our compare. CMP store pointer, and we want it, we know that now store pointer is equaling all these values right here. We want it to, if it's equal to 1, we want it to jump if not equal to code. And since we know that since Eric and Dave are both equal to 1, they're not going to jump to code, they're going to keep going down the list. So we're going to modify what writes to their addresses. I'm just going to have it move and a float 100 just for the sake of time. Take that off here. So it's just going to keep moving 100 into there, and it's just going to keep subtracting from Allen Kit as normal. Now make sure that you understand that we need to put the registries back the way they need to be. So we need to pop in reverse order. So if you put RAX, RCX, you need to pop it in reverse order. Okay, so if I pushed RCX first and then RAX, I'd have to do it RAX, RCX down here. So you pop it back off the stack in reverse order. Okay, it goes onto the stack, then you're putting something on top of it. Well, you got to take the top back off first. So since we put RCX on top of RAX, because we already pushed it onto the stack, we got to take it back off in reverse order. If we did it opposite, then RCX was going to equal whatever RAX was. We don't want that to happen. We want them to go back to their normal values correctly. It's hard to explain that one without showing some type of visual. I apologize about that. So let's assign that to the current cheat table. Did it twice. Delete this record here. Just going to name that multi-compare script. Oh, and something else I just messed up on. Let's bring this back up. Remember, Hal and Kit are not coming down here for that pop to take effect. They're going to be jumping right here, so we also need to pop it down here as well. And I make this mistake a lot. You will too, and the game will crash on you. You won't know why. That will be why. If you put it after your jump, then you're going to have to put it twice. Or you will have to just make a separate location that it automatically jumps to pop it and whatever. I'll let you figure that out from there. But for right now, Hal and Kit, it needs to be popped off when they jump down here, and then Dave and Eric, it'll be popped off when they jump here. So let's see if it works. Let's go back to our game. We're turning our code on. Dave and Eric should go to 100. Hal and Kit should be going down. They are. And you see Dave and Eric are going to 100. And we successfully used a multi-level pointer as a compare. So restart the game in autoplay. Boom. And there we go. Multi-level pointers. Now, like I say, I'm still in the process of kind of learning this. So what you want to do is go over here to this page here. Answer gives a great explanation of it right here. I want to give him the shout out and the credit for this. His post on here helped me learn to do this too. Plus it's something new that you have in your tool belt. Probably not something you're going to use very often. Like I say, this is more like a last resort type method. But it is another method that you can possibly use if you're having trouble finding compares. And believe me, using tons of compares and trying to find these things can get very tedious, I know. But hopefully you can take that with you, get whatever you can out of it, put it in your hacking tool belt, and now you got something else you're armed with to help defeat these things. But like I say, that's what we do. We're just here to learn. Even if we never use it, at least we know how to now, right? Alright. But that's it for this go around. If you don't mind, come over and check us out at our Facebook group. I'll leave the link for you down in the description. We've got a lot of great game hackers that hang out there that if they can answer your questions, they'll certainly do so. We're also getting a website going that will be at cheatthegame.net. It's still not up and running as of yet, but it is getting close. I'll keep you up to date on that as well. And also, my admins opened up a new Discord channel. We're still trying to figure that thing out. I've never personally used it myself, but people there are starting to use it, and I'll leave that link for you in the description as well if you would like to come onto the Discord channel. It's possible that we can get some game hackers in there later, or schedule a time to have some one-on-one tutorial sessions, and I may do that as well in the future also when I get the time to. So we're trying to get more things up and running for you guys to help you guys out as best we can, and just keep in touch with the Facebook page. All updated information is posted there as well. Alright guys, I'm out of here. You all take care. Keep on hacking. Most importantly, please enjoy yourself. That's really what it's all about. You cheat the game, fellas, because believe me, it doesn't mind cheating you. You all take care now.